Okay, hello everyone. I'll be sharing with you the electrical system and what to take note of. So electricity is the flow of electrical charges. And what are these electrical charges? These are the ones that are able to have different positive and negative charges that can move around the electrical system, but they are mainly in the negative charge. So when the electrical charge flow, right, they will actually tend to carry an energy form, and this energy is in the form of electricity, and this actually is able to change into other forms of energy when it transfer from the electrical appliances. So when we look at energy, we look at what is the law of conservation of energy, where energy can actually be converted from one form to another form. Okay, and it is important that you need to know how to draw electrical symbols. So one way is we look at the battery. Okay, the battery has a long line and a short line. The long will represent the positive terminal of the battery, while the short end will represent the negative end of the battery. So another thing to take note is when you have multiple batteries coming together, right, it will look like this. Now it is crucial that you could also draw the symbols so that it annotates where the positive terminal is and where the negative terminal is, and it helps to actually inform you where to connect in your voltmeter as well as ammeter. Next, we have the light bulb, which is just a circular and an X, a switch that is open circle with a line to represent that this is actually not open yet. That means this is open and not closed. Why? In this case, electrical current is not able to flow through completely. By closing it, a switch that is closed represents something like this, where the two lines are touching each other. You have a resistor. This resistor is actually a fixed resistor. That means it will not be able to change its resistance along the way. It's just a rectangle box. For variable resistor, they tend to have a difference in the arrow. And do take note that the arrow is always pointing diagonally upwards. Okay. Next, we have the voltmeter and the ammeter. The ammeter generally measures current. The voltmeter measures the potential difference. Do take note that for the connection, right, there is also a positive and negative terminal for the voltmeter and ammeter, where the positive terminal must always be connected to the positive end of the battery, and the negative terminal should always be connected to the negative end of the battery, and vice versa. So this one, do take note. It's also good to have a good habit to just also indicate on the diagram which is the positive and which is the negative terminal. So in general, for any complete electrical circuit, you will actually have a few main components, which is number one, you have an electrical source. This electrical source usually comes from a cell, which is another name for battery. Okay, and this will be an electrical cell. And then you have the wires to connect it. The switch and an electrical component can be a light bulb or a resistor. So how would you be able to draw it into an electrical circuit diagram? It can be done in this way, where this will represent the source, which is the cell, followed by the wire, the switch, because in this case is closed, and the light bulb, which is the electrical component. In exam, try to use your ruler to draw the electrical the diagram, and that this conducting wire generally shows the pathway in which the currents will actually flow from one end to another end. Okay, and electricity can only flow continuously in a closed circuit. So in the event that there is something that it's an open circuit, for example like this, this will indicate that the current will not be able to flow through, and therefore when the current is not able to flow through, your light bulb will not be able to light up. So light bulbs will not be able to light up in an open circuit arrangement. Okay, like this. Whereas in a closed circuit arrangement, light bulb can actually light up. So there is two main types of circuit, the series circuit as well as the parallel circuit. Now in a series circuit, right, what they meant is there is only one pathway for electrical current to flow through. In this case, right, any other path alternating or diverging from where it's supposed to move, it's no longer known as a series circuit, rather it's a parallel circuit. So over here you could see that there is two light bulbs and a resistor that is arranged in a series, so it's one straight rod. And that if there's any breakage, let's say this becomes a open circuit, the whole current flow will be disrupted and therefore it will not be able to light up any of the light bulbs. Okay. On the other hand, a parallel circuit is where you have multiple loops. For example, this is one loop, this is another path, and lastly, this is one last pathway. So you could see that generally there is three main pathways that it can be moved back to the circuit. And in this case, right, there are two bulbs and one resistor that is always connected in a parallel arrangement. So what is one advantage of this is that if there's any breakage or voltage, right, the light bulb will still be able to, the other light bulbs that is not affected can still light up. For example, if let's say this particular loop is being open, this light bulb will be then not able to light up. However, the other light bulbs will be able to light up. Okay, resistor is just a resistor, so it will not be able to do any form of lighting up. However, it can also control the brightness of the light bulb. Next, we look at electrical current. How do we go about measuring this? So what is an electrical current? It is the rate at which the electrical charge flows. So this one is important for definition as an exam. So through this, what you can do is you want to find current. It will be the number of charges flowing, so charge flowing over time. This is if you want to measure current. However, this formula is generally applied in upper sec and not secondary 2 or 1. Okay. And what's the SI unit for electrical current? It is ampere with a capital A. So do take note that in exam, if you are required to name, you have to spell it out in full. If you are required to state or to write the symbol, this is the one that is important. Now, another thing to understand is that for current, the way to measure is we use an ammeter. An ammeter is basically the instrument that we saw previously over here. This thing to measure the amount of current the circuit has. And for this to work, the ammeter has to be connected in a series arrangement, and that the terminal should be following the symbol, like positive in this case, and the negative portion of the battery. In the event you swap the wiring, what will happen is your ammeter reading will actually move in the opposite direction. It will give you a negative reading. So when you do your practical, when you realize that you have a negative reading, do try to swap the wire so that you can actually measure it properly. Okay. Next, we have conventional current. So conventional current is basically talking about the movement of current from the positive terminal to the negative terminal. Another word for conventional current, in some papers they will use it as direct current. Now when we look at electron flow is actually the opposite movement, where we are looking at electron flow from the negative terminal to the positive terminal. So if you are required to draw, the one in blue represents the electron flow, and the reference point is always from the battery over here. On the other hand, when we look at conventional current, it is from the positive terminal moving to the negative terminal, which is the one in red. In exam, they may ask you to label direction in terms of is it convectional current or electron flow. Okay, in our studies usually we use conventional current to explain most of our stuff. So an ammeter can be used to measure the current, and that this ammeter has to be connected in a series arrangement. Series meaning in one single form or side by side from each other. Okay, and like what I say, positive terminal of the ammeter has to be connected to the positive terminal of the source, which is the battery. Negative would be to the negative terminal of the battery. So what we have done so far is we have already talked about what is the current, what is the symbols, and what generally makes up an electrical circuit. Next, we look at the potential difference. A potential difference is usually measured in the form of voltage, and that it is generally the amount of energy needed to push the electrical charge to move from one point to another point. So let's imagine you have this flow of current. So or a flow of water. So the water will generally flow downwards. Okay, the water particle is known as your current. It's known as your charge. The rate of how the water flow is actually known as your current. The amount of energy used, maybe you have a motor here to generate that energy push, that is actually your potential difference. Okay, so in this case, we can try to illustrate how the whole thing can actually move. So if let's say it's an open circuit, like what we see over here in the picture, there is no electricity in the circuit because the wires charges do not move in the conducting wire. Okay, and the amount of energy required to drive across 2 points is what we call the potential difference, and this is usually defined as the energy required to move a unit charge between 2 points of a circuit. So one thing to actually help to generate that potential difference is from the battery, which is its source. So what we can see, it's a potential difference between two terminals, which is this is the positive and this is the negative terminal, and this difference of power will help to push down the electrical energy. So this one you can also visualize it as a slope, where the more steeper the slope is, as you move downwards, you're going to move a lot faster. If you're able to move down the slope faster, your current will be a lot higher. The flow of the charges will also be faster. However, if you have a more gradual slope, like this, your current is still moving, but not as fast as a steeper slope. So in this case, we call this having a higher potential difference, and this will have a lower potential difference. And how we represent it is by volt, the SI unit for potential difference. Meaning for every 1 volt of a cell, it will be able, 1 joules of energy is required to pull down 1 electrical charges. And how to measure this voltage? It is using the voltmeter. One thing about the voltmeter is, just like the ammeter, you need to connect it using the positive and negative terminal. However, one crucial difference is that a voltmeter is measured in parallel rather than it being side by side of a actual item. So this is how it looks like. If you want to measure the voltage of the cell, you draw a parallel arrangement at the cell. If you are interested to measure the voltage of the light bulb, you have to draw another parallel. An ammeter, generally you just have to draw it at the side here. Okay. Next we look at resistance. Resistance is the opposition to the flow of electrical charges of the circuit. In other words, if let's say you are moving in front and someone is actually pushing you backwards, that person is something like a resistance to use to move forward. So same thing. Over here, resistance is how the flow is actually being disrupted. So imagine if the same flow of water coming down, but along the way you have maybe some rocks. some rocks position along the flow chart. This will actually help to minimize or stop or slow down your current flow, and these are what we call like it acts as the resistance of the circuit. And how do you measure resistance? Is basically potential difference over current. This is an important exam question when they ask you in terms of if you plot a graph and they ask you for the relationship. So this is the main relationship between resistance and current, where if let's say the voltage increase, resistance will increase, voltage increase, current increase, and vice versa. To calculate voltage equals to current times resistance, or you can use this formula. Now the SI unit for resistance is ohm, or what we look like an omega sign, and this resistor in an electrical component can be used to resist the flow of an electrical circuit, electrical current in a circuit. How is it arranged? It is generally arranged in a series arrangement. Okay. Well, there are two main types of resistor: the fixed resistor and the variable resistor. The fixed resistor, you can't really control the amount of current flow in a circuit. However, the variable resistor, you can actually control the amount of resistance flowing in the circuit. For example, in the household, when you want to adjust the speed of your fan, there's an example of a variable resistor. So these are some ways in which resistance can be varied. Now, another thing to note is that for resistance, right, in a wire, it is being influenced by two main things: the length of the wire as well as the thickness. Thickness meaning how large is the cross-sectional area of the wire. So imagine it this way: if you have a road, a very long road, and you have cars moving in, it will take a lot of time for the cars to move along the long road. So the rate in which the car is moving is actually very slow to reach from point A to point B. Same thing when we look at current. If the length of the wire is very long, it takes a very long time for the current to flow from one end to another end. Therefore, the resistance is high. When we look at thickness of the wire, if the wire is very large, more cars or more charge can actually be able to move past it faster, and therefore this would represent the current flow will be high, therefore lower resistance. However, if the wire is very thin, only maybe one charge can move in a single file upwards, this will greatly slow down the rate of movement of charges, therefore lower current, hence you have a greater resistance. So this one is low resistance, high current. High resistance, low current. How do we then calculate total resistance in a series arrangement? You just have to add all of them up together. In other words, let's say we look at this circuit where there is actually R1, R2 and R3. So how to calculate a total resistance is just basically taking R1 plus R2 plus R3. This is the total resistance. This is what we meant by sum. However, if it's in a parallel arrangement like this, then you have to take the sum of the reciprocal of the resistance, meaning 1 over RT total equals to 1 over R1 plus 1 over R2 plus 1 over R3. After you have calculated, please remember to flip your answer again to find the total resistance. This step is usually missing in a lot of students' work. Okay. Another common question is that can be asked is, let's say if I were to increase more resistance in a parallel arrangement, how will it affect the brightness of the light bulb? So do remember that when you increase resistance in parallel, you would actually increase the current, and having more current, you would have a more light brightness. However, if you increase resistance in a series, the current would actually decrease. So this is the main difference in relationship. You will decrease current flow, and therefore the light will be dimmer. Okay, so just now we went to do some calculations which involves resistance as well as current. Okay, now we look into how electrical currents have its effects for heating, for magnetism, as well as the chemical effect. So for heating, right, electrical energy can be converted into heat energy, and this is usually controlled using the resistance of an electrical conductor, where having a greater resistance, you will actually trap or restrict movement of current, making it to be actually more heat generated. So an example would be your nichrome, which has a very high heat resistance, high resistance to electricity than copper. Therefore, nichrome wire is actually a better heating element as compared to your copper. Another example of electrical conductors that gives us a lot of heat is actually your tungsten. So your tungsten will be found in the filament of your light bulb, and this will be able to glow brightly as well. For your magnetic effect, electrical current can induce magnetic effect. Now what do we mean by induce? Induce means we create, okay, artificially. So using electrical current, we wrap around, let's say, an iron rod. We will be able to, and turn on the electricity, we will actually be able to supercharge the iron rod so that it becomes an electromagnet. When we talk about electromagnet, it means a magnet that is being created from using electricity. However, when you stop the electrical current, right, this electromagnet will actually lose its magnetism, and therefore it will not be a magnet anymore. So there are some examples in which it can be used. For example, your doorbell, such that when you press the doorbell at A, you will close the circuit. This closed circuit will then cause your iron rod to become magnetized. And when your iron rod is magnetized, this will actually cause another metal piece from the other side to close, to actually be attracted to heat your bell. So it will always constantly do this in order for you to actually create that form of attraction. You can pause the video to read up more about it. Lastly, for chemical effect, chemical change caused by electricity is what we call electrolysis, and this electrolyte is either a liquid or a solution which can conduct electricity through it. So mainly is to use electrical charges to take up all the ions, to move the ions to create a chemical reaction. Okay, and some of the common use is like electroplating. What is electroplating? Like for example, you want to coat a spoon to be gold, or in this case to be copper. You will put the metal over at one end, and you put the item that you want to actually coat in the other end, and you supply it with electrical current. Some of you may wonder, shouldn't you have a closed circuit when there's no wire to close it, to have the electrical circuit to be complete for electrical current to flow through? The answer is because down here the electrolyte, right, is actually a very good conductor of electricity. So it acts as a wire between the two items, and therefore it forms a complete circuit for current to flow through. And some purpose for this electroplating can be to prevent rusting, as well as to make an object to be more appealing or attractive. Another way is to extract relevant metals from a raw material, from an impure material. You can also use electroplating. Okay. So generally, this is the first part of electricity that you all need to take note of. I've already explained what are the common symbols for electricity and electrical circuit. I have also explained what's a series and parallel arrangement, how to calculate resistance, and finally what are some of the effects of electrical current. In the next video, we will be talking about what are some practical electrical uses, like calculating your electrical costs as well as the dangers of electricity. Until next time.